All right, this is for Algebra 2, Lesson 19. So, all of these problems have to do with distance. So I want you to remember that distance equals rate times time. That's the main thing to remember. And for every one of these problems, I want you to set up one of these little charts that look like this. I make this one just a little bit bigger. Looks like this. Remember, distance equals rate times time. Okay? So it should look something like that because we're going to always have two scenarios. So let's look at this first problem. It says, two trains left the station at 8:30, traveling in opposite directions. So here's my train station. I've got these trains, and they're going in opposite directions like this. Look at this. The first train. So I'm going to call this first line is going to represent my first train. This line is going to represent my second train because I got two different trains, two different scenarios going on. So the first train traveled at 50 miles per hour. Now that's a rate, so I'm going to put a 50 right here. The second was going 90 miles per hour. What time will it be when the trains are 350 miles apart? I need this total distance right here to be 350 miles. All right. Now, I do not know how long. I do not know the time, but they left. I'm assuming. It doesn't say otherwise. I'm assuming they left at the same time. So I'm going to make both of these just a T to represent my time. Now, what goes in here, you just always multiply these two together. So this would be 50T, and this one would be 90T. Okay? This is the distance that the first train went, because it's under the D. This is the distance that the second train went. Now, I know together, and I want to see this equation. Together, they went a total of 350 miles. So this is your equation. Now solve it. What's that going to be? 140T equals 350. Okay. Divide both sides by 140. And you get, let me get, I think it's 2.5, but let me hit it in my calculator. 350 divided by 140. You don't have to show my calculator. It's 2.5. Okay. Now, this is how long they traveled. You know, train 1 went 2.5 hours, train 2 went 2.5 hours. But look what it asked. It says, what time will it be? Okay, no big deal. 8:30, 2 hours would be what, 10:30? So it's supposed to be 11 o'clock a.m.
Yeah, I was going to say you have to add the a.m.
Yeah. Okay, so let's look at number 2. And I'm just going to write right here on this. So again, we're talking about distance, so I always want one of these little charts. So I'm going to do my little chart right here. How's my photographer doing? My camera woman?
I'm doing good.
All right, distance equals rate times time. Let's see what we've got here. We've got a horse who's trotting and walking. So we have two scenarios. Here's where it's going to trot. Here's where it's going to walk. So we always have two different things going on. Now look, the horse trotted at 12 miles per hour. So that's a rate. He walked at 5 miles per hour for a total distance of 39. So here's my little horsey right here. Here he is. I know. So he's going to run along for a little while, and then he's going to get pooped, and then he's going to keep going. This total distance right here is 39 miles. So obviously we're going to have to add up my two distances together to get 39. Here's the deal. I don't know how long. It says he did a total of 5 hours. I don't know how long he trotted, okay? But they're not the same amount of time. What you're going to have to do here is do the total time, which was 5 hours, and subtract however long he trotted, okay? So you can see, do you see how these add up to 5 if you would add those up together? Anytime they don't travel the same amount of time, you're going to have to do something like this, okay? Now to go in here, you're going to take 12 times t, rate times time, so that's what's going to go here is 12t. When you multiply these two together, make sure you distribute. It's going to be 25 minus 5t. Okay, make sure you distribute that in. Now, this 12t, that's the distance that he trotted. This ugliness right here, 25 minus 5t, that's the distance the horse walked. Together, let's add them together. It's supposed to be 39. Because that's what it said. Total distance is 39. So 12t minus 5t is what? 7t? Subtract 25 from both sides. That's going to give me what? 14? So I can see t is 2. Now let's see. What did it ask? Now before I even look what it asked, let's see what I found. T is 2. That's the amount of time that the horse trotted. Okay? How long did the horse trot? 2 hours. That's it. I already had found it. If it would have asked how long did he walk, well, you would put a little 2 in there. 5 minus 2 is 3. He would have walked 3 hours. Okay, let's try another one. We got the prodigal son and his father. They began running toward each other when they were 1 mile apart. So here they are. Here's the little dad. Here's the wheel boy right there. They're running towards each other. And they start to see each other. They're so excited. This total distance here is 1. All right? We're assuming they saw each other and they started running towards each other at the same time. Now, we've got a distance problem going on. So, yes, I want this box. Make me happy. Here's Dad. Here's the father. And here's the son. Distance equals rate times time. That's right. So let's see what we got. The father ran at a rate of 10 miles an hour. So that's his rate. The son, who was very weak and tired because he'd been eating with the pigs, he only ran at a rate of 5 miles per hour. How long did it take them to meet? Okay, remember their time should be the same. They saw each other and that's when they started running towards each other. So in this case, this is when they're easy, is when the time is the same. So we're going to have here distance equals rate times time. So just multiply these two together. These two added together, that's the two distance, should equal the total distance, which is 1. So notice we get 15t equals 1, or t equals 1/15. It's 1/15 of an hour, okay? How long did it take them to meet? Well, who would ever say, oh, it took me 1/15 of an hour? So let's put it in minutes. Okay, we all know there's 60 minutes in an hour. So let's multiply this by 60, which 15 goes into 60, I believe, 4 times. So it should be 4 minutes. Okay, and we're going to try another one. Look, it bled through. I can't do this. I'm going to need some scrap paper. This is terrible, terrible, terrible. Let me see. Just a minute, cameraman. Just hang steady. Keep the crowds entertained for a second. Oh.
Yep, I'm entertaining the crowds.
Okay, good. Thank you.
I'm going to take a drink of coffee.
Okay. No, there's no drinking on the job.
Sorry.
Okay. Madison walked north at 3 miles per hour, and Logan. Okay, look, I got Madison and Logan. Here's my 2 scenarios again. So do your little chart. I've got Maddie here, and here's Logan. And I know distance equals rate times time. Okay. Madison walked north at 3 miles per hour. That's her rate. Logan left 1 hour later. Ooh, my time is going to be different, so it's going to be a little trickier. Love it. Walked south at 5 miles per hour. So look, here's Madison. She's walking this way. Logan's walking this way. They're walking opposite directions. Okay, I do not know how long Madison walked. It doesn't tell me that. But I know Logan left 1 hour later. So however long she walked, he walked an hour less. Do you see how I subtracted 1 right there? So again, once you figure this out, that's the tricky part. So my distance here is 3t, because you just multiply those two together. Here I would get 5t minus 5. Don't forget to distribute. This total distance, add them together, equals, how far did they go? 19 miles. This is what, 8t, add 5 to both sides, and we get what, 24, so t equals 3. What does that tell me? Well, that's my t, so I look here. Oh, t is my time. 3 hours is how long Madison walked, okay? You can see that Logan walked 2 hours. It says, what time was it when they were 19 miles apart? Well, if she walked for 3 hours and she left at 2:30, that means it would be 5:30, okay, when they were 19 miles apart. That simple. Okay, we're going to do one more, and then we will call it a quits for this chapter, for this lesson. Okay, I like this one too. Another distance problem. Surely I've got 2 scenarios going on, so I'm just going to go ahead and do this. Distance equals rate times time. For the first part of my trip, I could average only 40 miles per hour. Later, I was able to travel at 65 miles per hour. So you could call this like leg 1 of the trip, and this is leg 2 of the trip, something like that. It took me a total of 7 hours to go a total distance of 360 miles. Okay, it took me 7 hours. Now, we didn't necessarily travel the same amount of time on each leg of the trip. But let's say I went that long on leg 1. Then how long did I go on leg 2? Well, remember it was a total of 7 hours. So it's going to be your total time minus however long you traveled on the first leg. Again and again, you do these the same way. To get the distance, multiply those two together. 65 times 7. Allison, do that in your head real quick.
Oh.
I beat you. 455 minus 65t. Okay, make sure again you distribute. These two distances together, I'm adding them together, is what? 360. So let's see, 40 minus 65, that's what, negative 15t? Wait, how about negative 25t? Wow, that would be bad. Subtract 450 from each side, 360 minus 455, that's negative 95.
You're not doing it in your head.
No, because I don't want to make a mistake on camera. Divide both sides by 25.
Oh, I can.
And we get 3.8. How long did I travel at each rate, at each leg? Well, on leg 1, you went 3.8 hours. On leg 2, you're going to have to do 7 minus 3.8, which is what? I should have been doing that one in my head. There's 3.2 hours. So that would be leg 1, and there would be leg 2. Okay, so try some of these. They're great fun.